Welcome back once again. My name is Mr. Charles Wenike. In today's video tutorial, we'll be discussing on dielectric loss part 2. A lot of people have been commenting on my video that I should also make videos on dielectric loss. So that is why I decided to make video on this particular topic. And I also believe that we will also discuss more on dielectric loss in time coming as well, in times of dielectric breakdown and in solid, liquid, and also in gas. But in today's video, I also think that I would like to remind you of what we have discussed so far in previous of our dielectric loss, which I specifically based on capacitor, and I also gave you some examples which I told you that dielectric loss depending on the material in which you are to use, and I mentioned some of them if I am not mistaken. And in that my former video, some people also said that my pronunciations or my pronunciation is not correct and so on and so forth. I also thank them because for them to remind me of my mistake. It's not about it. I also tell them thank you for telling me and also correcting me where I have not where my mistake is, because nobody is also perfect. So in today's video, I would like to take you back on the previous things that I discussed on dielectric loss. And I also want to remind you or told you that dielectric loss, it has various definitions. And that various definition depending on the particular material or on the particular and something that you are using it for, just as I said, particular material as well. Now if we are to discuss, let me take you back on my previous video of what I told you about dielectric in terms of the definition. And I told you that the dielectric, the term dielectric loss refer to the energy that is lost to heating of an object, which that was the definition that I gave you. I also said or is the loss occurring in the linkage resistance of the dielectric. And those definitions are true. That those definitions are based on the capacitor, and the kind of material that you are using in the same capacitor, because there are types of capacitor. Those types of the capacitor specify the dielectric that you are using. So in that also, that I also want to remind you that dielectric loss depend on the material in which you are using. You may decide to use any kind of dielectric material based on what you want to use it for, and don't expect that the other temperature will be the same thing as the other material, because their materials are different in diameter and in different areas. So in that case, I also want to remind you that voltage applied in different material have losses at different frequency. The voltage applied in different materials, it also have different losses, and different losses at different frequencies. Why is it like that? The voltage that maybe you use in electrical cable might not be the voltage that you will use in capacitor, because in capacitor we have a capacitor that they are mainly for DC, while we also have a capacitor that they are mainly for DC and for AC. We also have a capacitor that are mainly for DC and AC voltages, depending on their capacitance and on their dielectric material used. So that is why I said voltage different material have different losses at different frequencies as well. Those are the things that I also want you to bear in mind, because it's very important that you should know all these things. If there is any question that you have not answered, or you don't really understand what dielectric, what it means by dielectric, you can as well email me, or you can as well comment that I should make a video on a specific so thing based on dielectric. Even if it's not on dielectric, you can also let me know on the kind of video that you want me to make. So in that case, let's move forward for today's class, which I have already given you exactly what we are about to proceed. So dielectric laws part 1 is the assumption of electrical energy by a dielectric material that is subjected to an alternating current field, is termed as dielectric laws. I repeat, the absorption of electrical energy by a dielectric material that is subjected to an alternating electric field is termed as dielectric laws. Now, what did I mean here? What I mean here, in terms of maybe we are using a copper to extend or to run on our electrical appliances. You know, copper, it absorbs more electrical power. It has more strength to withstand any kind of voltages than aluminium. So I am using copper as an example to explain the definition aspect of this one, being the AC aspect of dielectric, because there are difference between AC dielectric and DC dielectric. But in this area now, I am using the AC aspect of it to define what I am explaining. I am also using copper as one of the strongest, as as one of the example to explain what I mean by this definition that you are seeing on the screen. So copper can withstand, and it can hold electric, absorb it properly, and transfer the signal straight to where you directed it to. So those are the things that the absorption of electrical energy a by a dielectric material that is subjected to an alternating electric field is termed as dielectric loss, because as long as an electric has been entered into that copper, depending, it could be 1.1 millimeter, being 1 mm, 2 mm, 1.5, depending on the copper diameter and so on and so forth. And that is how the strength and the absorbing and to absorb the strength will also required. So in that case, now this is another definition. Dielectric loss is an energy loss in a dielectric material as heat dissipation due to cycle of current alternate in a period of time. All these ones, what I've just said, is also part of the copper. And how do you understand, and how does it work? How does this particular one work? Now I say in electric, in alternating current system, dielectric material charge in first is just like once an electric have entered into any of the copper cable, what it does is to charge first by one direction and then discharge and recharge by opposite direction of current flow, and that is how it works. So in that case, This repetition system causes of unproductive heat generation, which defined as dielectric loss. And that is the same thing as copper, how it works. Even if it's not copper, I use copper as an example. Aluminium can also do the job depending on what you are about to do. And that is why I also make that I use copper as an example because from the definition here, dielectric loss is an energy lost in a dielectric material as heat dispersation due to cycle of current alternating in a period of time, because there is every current going into a copper. It is a period of time. It could be short period of time, long period of time, or depending on the particular time. But one thing I also want you to understand is this. In alternating current system, dielectric did what? It charged enforced by one direction and discharge and recharge by opposite direction of the current flow. So that is how it works. And this repetition system causes of unproductive heat generation, which defined the dielectric in every dielectric material, but the strengths are different. And that is what I also want you to understand this. So these are just the explanation of what I just said now. So another one is dielectric loss. In the same thing, losses is the same thing as it is because I am explaining bit by bit. So dielectric losses, any dielectric material may be characterized as a series capacitance and resistance, because the capacitance here is the volume is the volume of any of the dielectric material can carry or that can withstand the current or the voltage that are coming into it. While this resistance is the one that can resist if that particular voltage or current is excessive, it will resist it a little bit to that strength of that dielectric. So that is how it is. So in that case, the conduction aspect of this element can be measured in terms of the parameters. What are the parameters? The parameters are the capacitance, and the second one is the tangent. Now, what do you understand by the parameters and tangent? Just as I said, capacitor is the volume it can carry. That is the volume that that particular material can withstand in terms of what you are about to apply it for, because each of them might not withstand the same voltage. Because if if one copper cable can withstand, let me just assume 250 volts, maybe the other one that is higher than it can also withstand more than that. Now you can also use our electrical like Nepal, I don't know, the generating company. The generating company, majority of them, they also use aluminium to extend it. I don't know if it is true or false, but I have seen most of them in my own country will they use aluminium. Some also use um, copper as well, all depending on individual usage. So in that case, it means that what I'm trying to explain here is the capacitance, because the capacitance, it helps to withstand the a particular voltage that particular material can carry, because the material will determine the capacitance of that material. While in this tangent is different from the other one, and the tangent, you can also call it tangent, or you can also call it dissipation factor. If you can't call it tangent, you can also call it dissipation factor. It measures the voltage current relationship brought about by the material. That is the work of this tangent or dissipation factor. So what it does is to measure the relationship current voltage brought about by the material, because every material, what this sergeant do is to measure the relationship voltage current that it has, and that is the work of it. That is why you are seeing it there as well. So if I may ask again, what do you understand? What is dielectric material? I know that I have treated this topic, this particular topic on dielectric material before so far, but I just want to use this just to remind you or to take you back on what that electric material is, so that if you have not seen it before, if you have not watched my video before, please go to my channel, Charles Electronics Tutorial, subscribe, and you can also watch other of my videos there as well. So in that case, what do you understand by dielectric materials? Now let me just give you some brief explanation of it. Now we have to talk about dielectric material is a poor electrical conductive material used as an insulator for electrical system. I have explained I use copper, I can also use aluminum, any kind of it. So many of them can be used as an example. But most importantly, just as I said previously, I used in my previous video, I used capacitor, mica, and so on as a dielectric material. But in this video, I think we will discuss more further on it and other areas of it. So that is what I said. In the next coming video, I think we'll be discussing on dielectric breakdown, solid, liquid, and also in gas, so that you will see how it works as well. So in this case now the dielectric material is a poor electrical conductive material used as an insulator for electrical system. Now let me just go another one, so that from there I can explain it more better, so that you will understand what it means in terms of dielectric material. Now the dielectric material is such a kind of insulator material that can be polarized when applied an electric field to it. How do you understand by polarized? Now, in that case, if I may talk about that in terms of polarized, and because I want to use this polarized to explain what it means by that electric material. Now, let me just use this. It's just having polarized, so say dielectric material having polarized properties, because every dielectric material, it has polarized property. I don't know if you understand that. For instance, capacitor like mica, it has polarized, and every other what is it called? Every other maybe cable, it also have polarized, because it will do what? What do you understand by that polarized property? It means that when electric material placed, when electric is placed on it, its charges get aligned. Now, what I mean by align is, in every electric material, once a current is applied to it, now what happens to it is it will only align. What do I mean by align? Align, it simply means those particles, it move. Once it have moved, that does not mean that it will generate electricity immediately. Now it would. Now there will be an attempt to flow, but current will not flow in that dielectric material. So that is why you see in majority of dielectric material, what happens is that once a voltage is applied in that electric in that material, what it does is it will do what? Polarize. That polarize, it means that there is those particles, those positive and negative particles, one of them will move. It will just make a slight move, which cannot be seen by eye. It can be seen by microscope. it will make a slight move. That does not mean that current will flow through it. Current will not flow. So that is how it is. In every dielectric material, that is what it means is that it is dielectric is a poor electrical conductive material, is a poor, which means it is used as an insulator electrical system. So I think I have explained what polarized means. That polarized is just any of the dielectric material, it has a polarized, and that is that. And that polarized is when maybe when a voltage is applied on any of the dielectric material, there is a shift on each of the electron, and that is not necessary that there will be a current flow. Current will not flow, but there must be a shift, just to let you know that a force has been applied on that particular material. Now, these are the examples of capacitors, which are the other examples of capacitors, or apart from the capacitor as well, examples of dielectric material, which is here is proclaim, plastics, glasses, mica, and the oxide of various metals, other metals, because there are also other metals which can also use as in dielectric as well, or an insulator. Now, what are they? And they are called electrical cable. What I said before. All these ones that you're seeing here are the examples of the dielectric material that can also be used in terms of electrical cable: PVC, HDPE, MDPE, IDPE, LADPE, SLDPE, and EPR, ETC are used as insulation, which is the dielectric material. So all these ones are in terms of electrical cable, because we also use cable in many areas in our life: electrical cable, networking cable, so on and so forth. There are numerously that we also use. So we also consider two things, just as I said, the capacitance and also the dissipation, the tangent or the dissipation factors of it. So those are the things that you also put in consideration once you are to use any of the dielectric locks in any of them, whether in DC or in AC. So I think today I would like to end this video here. Please, if you have anything to say on what I just explained, if there is any mistake, if there are things that I am supposed to say and I did not say it, please, you can also comment. And I also expect more video on dielectric laws. And please, I would like to say, if you like my video, subscribe to my channel, comment, like, and share. Thank you once again. See you next week.